digital communication subject. Today our topic is synchronous and asynchronous communication. Okay. Upon completion of this period, we will be able to understand what is meant by synchronous communication, asynchronous communication, advantages of synchronous and asynchronous communication, comparison between synchronous and asynchronous communication. So prior to this, we should know what is meant by communication. Communication means transferring of information or sharing of information from transmitter towards the receiver, or from one person to other person, or from source to destination. Sharing of information or mutually exchanging of data is termed as communication, we call it as. So what is meant by synchronous and asynchronous communication? Due to the development of computer electronics, communication has become faster, cheaper, reliable, accurate, and timely delivery to the destination. So, whenever you are using computer electronics, communication has become faster, cheaper, reliable, accurate. So, already we had gone through difference between analog communication and digital communication. For digital communication, why we are opting is for ease of operation, simplicity, and for security purpose, and for achieving higher accuracy, we are opting this digital communication. So this digital communication is developed by using computer electronics. So by using this computer electronics, communication has become faster, cheaper, reliable, accurate, and timely delivery to the destination. So the transmitter station, say computer A, is connected to another station to receive data, say computer B, through a network or a channel. So generally, whenever you are taking any of information, you will when you want to communicate the information, you have transmitter and receiver. In between a transmitter and receiver, whatever the data we are exchanging will be done using channel, which is nothing but a medium, we call it as. Okay, medium which conveys the information from transmitter towards the receiver. So that will be done using a network or a channel. So channel or medium are generally of two types. They are wired and wireless. Wired and wireless channels will be there. So based on that, data will be communicated. Physically, if a path exists between the transmitter and receiver, it is termed as wired channel, we call it as. If there is no transmission path, but the data can be communicated through air acts as a medium, it is termed as wireless communication, we call it as. So the transmitter station say computer A, is connected to another station to receive the data, say computer B, through a network or a channel. So this is given on the screen. Now the question arises as to what should the arrangement and agreement between the two computers A and B so as to effectively exchange the information. It is resolved as synchronous and asynchronous methods of exchange of information. So now what is meant by synchronous and what is meant by asynchronous methods? Let's discuss in detail. Asynchronous communication specifies that transmitter and receiver clocks are free running and sets to approximately same speed. Provides a simple, convenient way to send data at lower rates without a lot of protocol. So generally what is meant by protocol is a set of rules that are assigned to perform a particular task. Here, protocol is a set of procedures that should be adopted between communication devices for efficient and orderly transfer or exchange of data. So whenever we are saying a synchronous type of communication, transmitter and receiver clocks are free running and sets up to approximately same speed. Provides a simple, convenient way to send data at lower rates without a lot of protocol. What is the protocol? Is a set of rules or a set of procedures that should be followed, that should be adopted between the communication devices for efficient and orderly transfer of information or exchange of data. In asynchronous communication, framing is based on single character. In synchronous communication, framing is based on block of data. So here, in asynchronous, the communication, the framing is based on a single character, whereas in synchronous communication, framing is based on blocks of data. Now I will discuss what is meant by synchronous. Synchronous specifies transmitter and receiver clocks are set to same frequency. Similar frequency and same frequency, there are a lot of difference between those two. So here synchronous specifies that transmitter and receiver clocks are set to same frequency, used for much higher performance terms in terms of data rates and protocols. High performance, in order to get the high performance and higher accuracy, we will go through synchronous type of transmitter. Transmitter and receiver clocks are free running and set to approximately the same speed. Example, computer keyboard. A framing is set by start bit. A stop bit is transmitted after each character. So, asynchronous type of communication consists of transmitter and receiver clocks are free running and set to approximately same speed. Example for computer keyboard. A framing is set by start bit. A stop bit is transmitted after each character. Asynchronous communication. A receiver having receiver and sender. Line idle A, line idle B, line idle. Start bits, stop bits. Asynchronous serial transmission. Asynchronous serial transmission. So here we are having start bits and stop bits. So asynchronous type of communication specifies that you are having a sender and a receiver. Line ID will be there, then B, line ID A, line B. So what it will do is stop bit you will having, start bits you are having. Again stop bits and start bits. See, mark and space are the now for 1 you are terminating mark, for 0 it is terminated as space. Start bit 7 data bits are there, parity bit and a stop bit. So one character specifies that you are having one stop bit, one start bit, one parity bit and 7 data bits. 7 plus 3, 10 bits will be there. So letter M, even parity. So even we are already aware that what in the even parity and what in the odd parity. So even parity specifies that in the given information, if you count all the ones, it should be even times. That is from the given parity we got us. So start bit, then 7 data bits, parity bit and the stop bit. That is letter 1, 2, 3, 4, 5, 6, 7 bits. 7 data bits. Parity is 0 as it is a even parity. Stop bit and start bit will be there. So what makes the difference between even parity and odd parity is, if you are saying here even parity specifies that number of ones are 1, 2, 3 and 4. 4 is even. So the parity bit that can be produced, parity bit can be taken as 0. If the number of digits here, number of ones are 3, at that instant the parity bit will become 1. So what it specifies is the overall information should be in terms of even. Asynchronous mode of data transfer, we are having clock pulse, transmitter and a receiver. Data that should be communicated. So transmitter and receiver operates at different individual frequencies. Data is to be transmitted along with the start bit. We have given how the data will be transmitted. We are having transmitter, we are having receiver. In the synchronous mode of data transfer, start and stop bits will be there and the data will be communicated. Synchronous communication. The transmitter receiver synchronous to the same clock frequency. It does not require start and stop bits. Efficiency determined by the ratio of number of character bits to the total number of bits. Using high speed communication and mainframe computers, it is quite complex. So whenever you are taking transmitter part, so transmitting the same clock pulse will be maintained in synchronous communication. It does not require start and stop bits. Efficiency is determined by the ratio of number of character bits to the total number of bits. Used in high speed and mainframe computers, quite complex. So synchronous communication, you are having sender and the receiver. Synchronous serial transmission. If you observe the screen, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1. If you see, whatever the data in a sync for synchronization specifies that same amount of information. That is using high-speed communication. Using high-speed communication mainframes. It is quite complex. The diagram, if you see, sender and a receiver, we have sync pulses are same clock pulses has to be maintained at both the transmitter and receiver. They had given a synchronous window length and the communication cycle period. Both the sync pulses have to maintain the same clock pulse. Asynchronous transmission and synchronous transmission. See, if you see on the screen, asynchronous type of transmission specifies that there are different, if you see this is different, this is different, this is 3, and again 2, 1, 2, 1. So what it specifies is there is no same clock pulse or same clock pulse is not there. No same clock pulse has been maintained. Here in the synchronous we are taking in an order. The same thing has been replicated at both the ends, but here it is maintained with if you have the same information that can be transmitted in an orderly manner and in an unorderly manner. So different time asynchronous we call it as, same time synchronous we call it as. So same place in person, different place online. So here what makes difference between this is different time zones. If you are taking it is only asynchronous we call it as, same time it is termed as synchronous. Same place in person, different place online. Synchronous and asynchronous type of transmissions. Synchronous, to compare synchronous transmission and synchronous transmission, what are the clock pulses? This can be observed. Clock pulses are perfectly synchronized, approximately synchronized. So that is the reason whenever we have taken synchronous time, same clock pulse will be maintained at both the transmitter and receiver. Start bits and stop bits are not used. As they are perfectly synchronized, there is no requirement for other bits, other extra bits like parity bits, start bit and stop bits. Here, whenever you are going for asynchronous type of transmission, as it is approximately synchronized, it requires start bit, stop bit, and parity bits also. Less number of bits are transmitted, more number of bits are transmitted. Overhead is less, overhead is more. Overhead is nothing but more number of bits. So that is the reason. Along with the required data, we are adding some start bits, stop bits, and parity bits. That is the reason overhead will be more. In synchronous comparison, no start bit and stop bits are present. That is the reason here overhead is less. Efficiency is more in synchronous type of transmission. Efficiency is less in the synchronous type of transmission. Quite complex system, quite simple system we call it as. But whenever you are looking for more accuracy and more efficient output, a synchronous type of information will be used. Synchronous transmission is used. So we had gone to a synchronous mode of transmitter and a synchronous mode of transmitter. Now we will discuss data is to be transmitted. Transmitter and receiver operate at different individual frequencies Data is to be transmitted along with the start bit. Now what is meant by start bit and what is meant by stop bits? So generally if you take 8 data bits, what is start bit and what is stop bit? Bit width is 4 microseconds. Data frame is 44 microseconds I had given you. So if you see more significant bit and the least significant bit will be there. Then start bit, stop bit and parity bits will be provided. So this on the screen 0 1, that is so if you take computer here and enter mark or ideal bits will count as next character being transmitted, parity bit, stop bit and the start bit along with the data that has to be transmitted. So here A is equal to 1 1 0 0 0 0 1, that is 7 bits will count as. Along with these 7 bits, now to type using a typewriter or a keyboard, if you type here, that has to be printed on the printer. So that you are using direction transfer, next character being transmitted. In between that you are having mark or ideal bits we call it as extra bits. Along with that you are having parity bit, stop bit and start bit. So these are the different types of bits that has been given. So the start and stop bit specifies that ideal state of line. Start bit you are having 5 to 8 data bits, then a parity bit, odd parity or even parity or unused, and stop element 1 to 2 bit times. Remain ideal or next start bit. So this is the character format they had given you. 8 bit asynchronous character string. We are having start bit, stop elements and second start bit. Unpredictable time interval between characters. Don't know how much amount of time the data will be exchanged, that is unpredictable time will be there. And then you are having data, stop element, start bit, and then in between the stop element and start bit of other 8 bits in asynchronous character string, there is having unpredictable time interval. So unpredictable time interval specifies that whatever data we are transmitting, we doesn't know at what instant of time the data will be transmitted. So 1 byte consists of start bit, stop bit and the data. Logic 1 and logic 0 will be indicated. Asynchronous serial data, it consists of start bit, ideal line state is 0 and the character that has been given. In order to transmit expected transmission and actual transmission, start bit, stop bit, sampling times and what are the data bits. The start bit is used for receiving the beginning bit of the character. Stop bit is used to indicate the receiver and the end of the character from the transmitter. If the start or stop bits are not set properly, the receiver fails to decode the characters in the asynchronous communication system. However, for transmission of every character, start-stop bits must be sent. This process increases overhead during the transmission. For example, if 100 characters are to be transmitted in ASCII code, the total message bits would be 100 into 700 message bits. The minimum additional start-stop bits required in asynchronous communication for transmission of 700 message bits are 200, assuming one start bit and one stop bit for every 7 character of 7 bits. 200. As asynchronous transmission, there is no set length of time between characters. Start and stop bits are used to identify the beginning and ending of the character. So what happens if we are using the start and stop bits in asynchronous type of communication? So in asynchronous type of communication, whatever the start bits and stop bits we are using, it depends upon the mode of transmission. If the mode of transmission is synchronous, there is no need of information, that is there is no need of start bit and stop bit. But whenever you are going for asynchronous type of communication, it requires this asynchronous type of communication. It requires start and stop bits along with the information. Just we will discuss about the topic that has been covered so far. Okay. Generally, in serial transmission, one bit follows another, so we need only one communication channel, that is transmitter. Parallel to serial converter, channel will have, and the receiver, this serial to parallel converter, and the receiver will be there. Advantage of serial transmission over parallel transmission is that only one communication channel is required, so cost will be low. So basically, serial transmission is classified into two types: synchronous transmission and asynchronous transmission. So now already we had gone through what is meant by synchronous type. Just we'll revise once again, and some of the points that will let you know. So generally in asynchronous transmission, we send one character with start and stop bits. In asynchronous system, transmitter and receiver clocks and free running are set to appropriately the same speed, but not exactly the same, set approximately to same speed. The purpose of start and stop bits in the asynchronous system is to identify the beginning and ending of the character by the receiver. A start bit is transmitted at the beginning of each frame, and at least one stop bit is sent at the end of the character. The stop bit leaves the line or channel which represents binary 1, and the start bit always represents by 0. So start bit is represented by 0, and you will have data bits, then you will have parity bit, then you will have stop bit. Stop bit is indicated by 1. Right? Is it clear? So generally what we are doing is, whenever you are going for asynchronous type of communication, you have the data that has to be transmitted, and the start bit will be there, and the parity bit will be there, then stop bit. So stop bit, parity bit, data, and the start bit. So start bit is always represented by binary 0, whereas stop bit is always represented by binary 1. Apart from that, you will have the data and the parity bits. So you will have start bit, stop bit, data bits, and the parity bit. And always stop bit is always represented by 1, and the start bit is represented by 0. One extra bit called the parity bit before a stop bit will be there. Parity bit is used for error detection and error control. So whatever the data that we are transmitting in asynchronous type of mode, what we are doing is we are having start bit, we are having data, and then we are having parity bit, and then we are having stop bit. So always start bit is indicated with binary bit 0, we are having data, and stop bit is indicated by binary 1. This parity bit, whatever we are using, is for error control. So in order to control errors, we are using this parity bit. Now we had data bits, stop bits, and the start bit. Direction of flow will be there. Sender and the receiver will be there based on the data that will be transmitted. So when you are taking, what are the advantages of synchronous and asynchronous type of transmission is, in synchronous, what are the advantages of synchronous and asynchronous type of transmission is, system complexity will be less. In asynchronous type of communication, no need for perfect synchronization between a transmitter and receiver. It is cheap. Disadvantages are, speed will be low, more number of bits are there, framing error due to mismatch in transmitter and receiver clocks, can be used for short distance communication only. More bits are there, that is the overhead will be more and efficiency will be low. What is the need for start and stop bits is, in asynchronous transmission, we send one character with start and stop bits. The purpose of start and stop bits in an asynchronous system is to identify the beginning and ending of each character by the character in the receiver. Start bit is transmitted at the beginning of each character, and at least one stop bit is sent at the end of the character. Stop bit leaves a line or channel which return binary 1 and the start bit always returns a binary 0. One extra bit called the parity bit will be there before the stop bit. Parity bit is used to control the error. So this is all about the asynchronous type of transmission. Due to the more number of bits, that is you are having start bit, stop bit, parity bit, overhead will be more. If overhead is more, efficiency will be less. So that are the disadvantages of asynchronous type of communication. Now coming to synchronous, what is the synchronous type of communication? Then we will discuss about what are advantages and disadvantages of synchronous type of transmission. So whenever you are taking a synchronous type of transmission, in synchronous transmission we send bits one after another without start and stop bits. So in synchronous communication, what we will do, we send bits one after another without the bits, that is extra bits, that is start bit and stop bit. In synchronous, transmitter and receiver are synchronized to the same clock frequency. If you remember, in asynchronous, synchronized to similar frequency, but here what we will do is we will maintain the same clock frequency. Synchronous communication is more efficient than asynchronous because start and stop bits are not necessary here. So synchronous transmission is faster than asynchronous transmission. For this reason, it is more useful for high-speed applications like transmission of data from one computer to another. Clock recovery. A synchronous digital system can function with the receiver clock whose speed is only approximately the same as the transmitter clock because the clock is reset at the start of each character. Simple crystal oscillators at each end running at the same nominal frequency. However, the longer message block used in synchronous communication makes it necessary to lock the two clocks together exactly. Otherwise, receiver clock would soon begin to sample the signals at the wrong time. So, clock recovery circuit should be maintained in synchronous communication. And framing. It is necessary to determine which bit represents the beginning of the character. In asynchronous communication, problem is solved by using start bit and stop bits for each character, but they add a great deal of overhead. In synchronous communication, it is only necessary to locate the beginning of the block of data. As long as the transmitter and receiver clocks remain synchronized without needing start bit and stop bits, synchronous systems can be much more efficient than asynchronous systems. So clock recovery will be maintained and framing will be maintained. So based on this, the advantages of synchronous transmission is high speed will be there, less bit overhead will be there because no start bit, stop bit or parity bits will be there. Efficiency will be very high. Better error control can be done, can be transmitted for longer distance communication. These are the advantages of synchronous type of transmission. The disadvantage is expensive. It needs perfect synchronization between a sender and a receiver. This transmitter and receiver system will be much complex. So based on this, you can differentiate the synchronous type of transmission and synchronous type of transmission. Now coming to the what is the essentiality of start bit and stop bit. So start bit and stop bit will be used for asynchronous type of communication. Here what we are doing is we are taking a data, how it can be transmitted based on the number of signals. So if you are taking parallel type of transmission, that is parallel data transmission, what happens? If you are taking serial, what happens? So based on these, the parallel and serial data is classified into this serial type of transmission is classified into synchronous transmission and asynchronous type of transmission. So what is the need for start and stop bits is a start bit is transmitted at the beginning of each character and at least one stop bit will be transmitted at the end of the character. So the purpose of this one in a synchronous type of system is to identify beginning and ending of the character in the receiver. So what in a synchronous type, what we will do is we will communicate or we will send one character with start bit and one character with stop bits. So based on that, we are generating the data. So I think now we are aware of what is the difference between what is the difference between synchronous type of transmission and asynchronous type of transmission. So prior to this, whenever you are transmitting the data, generally you have serial type of transmission and parallel type of transmission. So So based on that only the data will be transmitted. So the transmission of binary data across a link can be accomplished in either a parallel or serial mode. So data transmission. So in digital communication systems, transmitted the signals by first converting analog signals into digital signals and then modulated. These modulated signals are digital rather than analog signals. It means that transmitted signals from the digital transmitter are discrete signals rather than continuous varying signals. So, these discrete signals are zeros and ones, which might be interchanging their levels, that is either 0 or 1 and vice versa, due to the presence of noise in the channel. These changes will completely change the data received at the output. So, this noise can be eliminated in digital communication by changing a single bit changes complete data of the message. So, these errors must be identified and corrected to record the original message of the signal. For this purpose, a variety of error detection and correction techniques will be employed. While using these detection and correction methods, transmitter and receiver must agree on same method. This chapter deals with some of the important error detection and correction methods which are widely used and already used in digital communication systems. So generally, you will have whenever you are taking a synchronous type of communication, you are having start bit, stop bit, and parity bit. Based on that, overhead will be more. So what is mean by overhead? Bit overhead specifies that the start bit, stop bit, and the parity bits are called as bit overhead. So what is overhead efficiency? Overhead efficiency of the communication system can be defined as number of data bits to the total number of bits. So the number of data bits and to the total number of bits will give you efficiency, where n is the number of data bits, n is the number of total bits. That is data bits, start bit and stop bit, and parity bits will be added. That is total number of bits we call it as. So based on that, you can generate the data. Efficiency of the system will be getting. So now transmission of binary data across a link is classified into two types, accomplished in either parallel or serial. This data transmission is classified into parallel transmission and serial transmission. This serial transmission is classified into synchronous type of transmission and asynchronous type of transmission. So now coming to what is in the parallel data transmission, what is in the serial data transmission. Okay, parallel data transmission specifies that in this transmission, n wires are used to send n bits at a time. So that way, each bit has its own wire, and all n bits of one group can be transmitted. So, for example, that we are having 8 bits. 8 wires are bundled in the cable with connector at each end. Advantage of this parallel transmission is speed will be more, but the disadvantage is parallel transmission requires n communication wire lines to transmit the n data bits. That's why it is very expensive. For each and every single bit, it requires certain paths should be maintained. So parallel transmission is used for only shorter distance communication. Whereas in serial type of communication, what we will do is one bit follows another. So we need only one communication channel. So that is the reason whenever you want to transmit for serial transmission, the transmitters, all the parallel to serial converters will be done. Then what we will do is we will take transmitter path. Then all the signals that has to be transmitted, they are converted from parallel to serial. Okay, so you will have parallel to serial converter which converts all the parallel signals into serial signal, and it is given to channel. At receiver, this serial to parallel converter will be used, and that is given to receiver. So what we are doing, it is similar to modulation techniques that will be done, and demodulation done at the receiver. So here also what we will do is, in order to maintain cost effective and in order to reduce the expensiveness, and in order to remove the disadvantages, that is it requires much of the information and it is used for only short distance. So this can be communicated for longer distances by converting these parallel signals into serial signals. So if you are converting parallel to serial, only one wire can instead of using, for example, whenever you had taken 8 bits in parallel communication, 8 wires will be used. So in order to avoid that, if you use a parallel to serial converter, you can directly take one wire to communicate these 8 bits. So this is nothing but parallel to serial converter, we call it as. That will be maintained at the transmitter part, and the information is given through the channel. At the receiving end, again the serial signal will be converted into parallel. That is, you will use serial to parallel converter, and you are having the receiver. So in this way the data will be communicated. Advantage of serial transmission over parallel transmission is that only one communication channel is required, so cost will be low. Again, this serial transmission is classified into two types: synchronous type of transmission and asynchronous type of transmission. What we had learned in the previous slides is same: synchronous and asynchronous type of transmission, we call it as. So already we are aware that asynchronous type consists of start bit, stop bit, and parity bits will be there. So what is the need for start bit and stop bit is how much of data has been moved will be depending upon the start bit and stop bit. So it says where the data gets started, and the parity bit specifies what is the error and how it can be controlled. So that is been done by parity bits, we call it as. Okay, one extra bit that is used for parity bit is for parity used to error control. So this is all about your start bits, stop bits, parity bits, and synchronous type of transmission, asynchronous type of transmission. So how we are converting serial to parallel and parallel to serial is we are using one device which is known as UART, we call it as. UART stands for Universal Asynchronous Receiver Transmitter. So this is a digital IC used to perform parallel to serial and serial to parallel data transfer. So most data transfers and operations inside the computer are parallel, but as we know, data communication is mainly serial binary data. UART performs the necessary conversions. So these different types of conversions from serial to parallel and parallel to serial will be done by using a device which is termed as UART, we call it as. That is Universal Synchronous Asynchronous Receiver Transmitter. That is UART, Universal Asynchronous Receiver and Transmitter, we call it as. So based on that, the data will be generated. Okay, this is all about your this is all about asynchronous type of transmission and synchronous type of transmission, and what is the need of start bit and stop bit. What are advantages of synchronous type of communication and advantages and disadvantages of asynchronous type of communication. So UART is a device which is used. It is a digital IC used to perform parallel to serial and serial to parallel data transfer. Most data transfers and operations inside the computer are parallel in nature. Okay, this is all about your transmission modes. So always remember that for a synchronous type of communication, framing is based on single character, and synchronous transmission is based on lots of data. Okay. See here, you can see start bit, stop bit. Whenever you are going for a synchronous type of communication, you are having 8 bits. This is the lowest bit, most significant bit, and the least significant bit. Start bit, stop bit, and the parity bit will be there. So the start bit, generally start bit is indicated by 0 and the stop bit is indicated by 1. This specifies that how the data has been transmitted. So if you take the data from is 44 microseconds and the bit width is 4 microseconds, it specifies. So based on this, you can generate the data and data can be assigned. So now they are taking this character. Direction of transfer is from this one to this one. So in order to write the A, that is 1 1 0 0 0 0 1. So this is on the screen. For serial cable, you are having a start bit. Start bit is indicated by 0, and the stop bit it is indicated by 1, and the parity bit. Based on the signals, if it is even parity, we can count it, and if it is odd parity we can count it. Based on the information the data will be transmitted. So the next character being transmitted, and the mark or ideal bits are maintained. Okay, in this way we'll transmit the data from transmitter towards the receiver. So just remember that asynchronous type of communication, bit efficiency will be less, but overall overhead bits will be more. Whereas in synchronous, bit efficiency will be high, and overhead will be less. So let's end the session. Thank you.